Welcome again, Vikram. So it was a great conversation with you in our last episode. And today, the key focus will be on the data infrastructure for LLMs. Right. So we talked about some of the challenges with data infrastructure, right? And I'm going to kind of deep dive and ask you some more questions around the data infrastructure.
Sure. Thank you so much, Paresh.
Okay, so we talked about getting context from our internal data sources, right? In
Yeah.
that, I've been hearing a lot about vector search and having a vector
Yeah.
search capability in the database. So,
Yeah.
what is your point of view on that? Because end of the day, it is all about the right data retrieved from your internal sources, which is relevant for your questions, right? So, like,
Correct.
what makes more sense based on a specific use case or variety of use cases? Right?
Right. So, so let's first talk about the structured data piece. I think that's where your interest is. Um, so when you're talking about relational databases, typically you have uh, lots of complex data distributed across multiple tables where you will need to do a lot of complex joins, right? Now, when you try to use vector databases. Typically, what is happening with a vector database is what it's taking is the basic underlying data store and translating it into what is called a vector, right? And that vector is supposed to capture all kind of semantic information. So when you try to translate a traditional relational database into a vector database, what you would typically do is maybe take each row or each column and start translating those into vectors which are stored in your vector database. Now, when you have lots of natural language queries coming into your system, typically the challenge that you'll have is that you'll have to do all kinds of, you'll have to understand the semantics of that question, translate it into the schema that you are using internally in your enterprise. And every enterprise, your column names could be different, will be weird, will be strange, etc. Right? It's unlikely that a vector database will out of the box, a RAG system or a generative system will understand what the user intent is versus what your internal schema is. That is one big challenge. The second big challenge that you'll have is that you will need to do complex joins across your tables to generate a very good answer, right? Now, this is not easy purely using vector databases. For this, a better solution would be using some kind of agents where you have human input or you enterprise, I would say expert system inputs, which allows you to understand what the schema of these tables are, what kind of joins are possible, for example, and then translate that. You use that to use let's say a SQL agent, which translates your natural language query using your expert system knowledge of the underlying tables and schema, etc., to translate it into a underlying relational query or a SQL query. That is a better approach compared to blindly using vector databases. Vector databases are great for POCs when you have a single table over which you want to do some question answering. It works great out of the box. But trust me, if you want to build an enterprise grade system based on this for complex database schemas and architectures which are there in enterprises, there is a lot more work to do. And the final big challenge you will always face is when you deal with vector databases, the output is not always explainable because the underlying models that you use is a black box, right? You will not have explainability. And if, a CXO level person comes and asks, hey, I asked this question, this is the answer that came out, this is nonsense. Why are you giving me this answer? You won't have an easy way to explain why that came about, right? So so you will need explainable systems. You will need sort of expert knowledge bases which help you to translate it, and which will be explainable at the end of the day, right? That's the only way to, that's in my opinion, given the current state of AI, that's the way to build out these architectures.
Yeah, absolutely.
Mm,
Like if I take an
mm,
example of a
mm.
banking or insurance use
Yeah,
case, right? So like
yeah.
what user or if you're building a
Mm,
system
mm,
targeted for end users.
Yeah.
Users want specific info, right, for them,
Yeah.
right? So like
Yeah.
all about retrieving that from your internal data store and giving that, right? It is giving
Yeah.
the specific data points for them that
Yeah.
should kind of help answer their questions or their
Exactly.
issues, right? So that's what
Yeah.
is needed, right?
Yeah.
So now you talked about SQL agents, right? So and then
Yeah.
how they can talk to the SQL databases.
Yeah.
So now comes a problem where there are
Mm.
n different kind of users, right? So
Mhm.
talking to your system. So how do you basically manage this in terms of roles of their users, and
Yeah.
which role of users are talking to a specific SQL agent, and then it translate into at a database level again, right? So
Yeah.
what are the challenges
Yeah.
there, and how can we solve that?
Yeah. So these are great questions, right? So at the end of the day, so what is exciting to me that's coming out of a lot of this generative AI aspect, etc., is this notion of agents, right? So there was a popular paper that came out about a year ago or more called React, right, which is a React and agent framework, right? So the idea there is when a question comes from an end user, you try to break it down into a set of steps as to how you will go about executing on that answer, right? Um, and then you sort of go around and evaluate, or you sort of execute each of those steps and get the final answer. So each of those steps could go to, for example, a different database. It could go to database one, it could go to table one, it could go to table two, get the answers from table one and table two, do a join, do some complex computation on it, and return an answer. Now, there are two more aspects that you spoke about, which is role-based access control and uh, and yeah, so this agent-based role-based access control, right? So the role-based access. So at the end of the day, with these agents, what you can do is you have an architecture which, first of all, understands the user query, can do a query classification, can do a role based classification, right? So the agent can say, for example, for this role, for this user, these are the tables I have access to. And I mean, you could have sort of row level access control also, but I won't go into that complexity. These are the tables you have access to. As a consequence, what are the steps that I need to get execute so that I can sort of get the answer for this user, because that role based access control is baked in at the time of planning out what steps I need to execute, right? Based on that, you say I can go to table for user A, he has access to table 3 and table 5. So I will go to table 3 and table 5, get the answers that are there from there, and try to return a solution based on this. So this agent based architecture is probably one of the most powerful things that we have coming out at this point of time.
If I understand that pretty
Mm,
well,
mm,
Vikram, so
mm,
what
mm,
you're telling is you
mm,
have this
mm.
from a data infrastructure point of view, you
Yeah,
need that fine-grained role-based access control
yeah,
configuration supported, right?
yeah.
Including
Mm.
specifying for a specific table or at a column
Yeah.
level. So it might be
Yes.
PII data. You should be able to encrypt it at a column level and so on. Right?
Exactly.
So those kind
Yeah.
of features should be available for you to support
Yeah.
this.
Exactly. And you can sort of bake it at the entry level into the agent itself. So the agent knows it's user A, it's Paresh coming to me. As a consequence, this is the data universe available to me based on the role-based access control. So now let me see how I can create these SQL queries to answer that question.
Makes sense. Makes sense. Yeah, this is
Mm,
great, right? So we have been
mm,
talking about this, and now
mm,
say we are building these great applications which
mm,
are GenAI powered. So
mm,
as we scale, right?
mm,
So I mean, like down the line, 1 year down the line, 2 years down the line.
mm.
So the scale is going to be huge, right? There are
Yeah.
like huge number of concurrent
Mm,
reads and writes coming through these applications.
yeah.
Now, how you think these applications can handle that scale, right?
Mm,
And again, one more question from data infrastructure perspective:
mm,
how your database should be to handle this scale in terms of the mere data size and also the performance, right? End of the
yeah.
day, the response should be given in say whatever milliseconds or whatever it
Yeah.
is. So
Yeah.
now how your database should handle that, right, in terms of performance and scale.
Yeah. So I think there are two answers to that, right? So, and I think Paresh, you and I discussed it, but we sort of swept it under the rug. which is that if see there's a lot of expertise that's been built over ages on doing relational databases at scale, having concurrency at scale, all of that, right? And performance and cost, right? It's tuned to a fantastic degree now. Now, if you go to vector databases, I mean, at the end of the day, a vector database is just a feature on a regular traditional database. You can think of it as. But there are two challenges with if you sort of take the vector database approach. If you take the vector database approach, one, there is a cost challenge. Two, there is a scale and performance challenge, both for writes and reads, right? For writes, you need to create what are called these semantic embeddings, which will mean you'll have to incur some AI cost, right? Which is could be in a GPU, CPU, whatever, right? Which is going to slow down your writes into the system. So if you're thinking of millions or billions of transactions into the system, right there you have a bottleneck with vector databases. Second, in terms of reads, right? To scale a vector database, right now they don't scale very well because of I can go into it, but there's something called an HNSW, uh, nearest neighbor search that they use, which doesn't scale well when you shard it. A lot of challenges with it. So the RAG architecture that we're talking about and the agent architecture we're talking about essentially hints at the fact that we should continue using traditional relational databases, but have a thin smart layer on top, which is translating your natural language queries using these agents into appropriate relational database queries, right? Now, if you architect that very well, you can leverage all the benefits of your traditional, all the smarts that were built over traditional relational databases over time, how to make it scale, how to have it asset compliant, how to distribute it, how to shard it, what are the kinds of right architectures for that. You can leverage all those benefits and still get the generative AI smarts on top of it. So it feels to the end user like he's having a chatbot like interface, but the under the hood, the sort of the rocket engine that's powering it is still the traditional relational database. You don't need to actually go to a vector database, and in my opinion is a big flaw in thinking that people have, because it's very easy to get a proof of concept thing going with a vector database today, with tools like LangChain, etc. But building it at scale, productionizing it, building it for enterprises, that approach is today the technology is not yet there. There's a lot of work that needs to be done.
That's a great learning for me actually, right? So what
Yeah.
you're really telling is you
Hmm.
use your
Hmm.
uh, the system of records database, right? So
Exactly.
and you rather add that intelligence on top of it with a thin
Yeah.
layer, right? So
Yeah.
and database will do its job, right? So you
Yeah.
basically have that natural language query converted into a SQL query, right? And
Yeah.
then hitting the database, and you are
Yeah.
not sacrificing your concurrency
Yeah.
performance so on, because
Exactly.
or these databases are tuned, right? My
Yeah. Yeah.
example, databases like Cockroach DB, right, which are distributed SQL
Yeah.
databases. That's all the beauty of the traditional
Exactly.
world, and which can scale and give you whatever number function
Exactly.
you want, right? So
Exactly.
this is right.
Yeah.
Now I just want to jump into like the last point, right? So where
Hmm.
we are talking about a lot of these getting insights from
Hmm.
your existing data. Now
Hmm.
as we move forward, the
Hmm.
world is moving towards even doing transactions through these
Yeah.
chatbots, right? So for
Yeah.
example, I can go
Hmm.
and ask, give my
Hmm.
specific requirements, and I can
Hmm.
book a ticket through the chatbot, right?
Yeah.
So now how this again translates
Yeah.
into kind of databases, right? So and then how do you
Hmm.
handle these transactions from these
Yeah.
prompts, right?
Yeah.
And
No, absolutely. That's a so this is sort of going away from the RAG piece, right? But if you think about what we just discussed, the architecture we just discussed, Paresh, which is use traditional databases but use generative AI as a thin layer on top, then it doesn't matter. Nothing is changing at the end of the day, right? Even if you want to do transactions, if you want to do writes, so far we have been talking about reads from the database. Now you want writes into write into the database, right? It's exactly the same. Again, if you don't think in the vector database world, but if you think about your traditional database world, we know how to do writes with transactions, asset compliance, all of that we know extremely well, right? Why reinvent that wheel? Again, add a thin layer on top that will allow you, which will give you the intelligence layer. Again, that's the system of record remains the same. Add a thin intelligence layer on top that will allow you to start doing, for example, booking a flight, making a bank transaction, depositing into a bank, making a payment transfer. All of that is very simple with a with a thin chat interface on top. Nothing changes under the hood. So, for Cockroach DB can remain Cockroach DB. Uh, and scale. It's a way more beautiful way of doing things. And even if you use a vector database, it might be a very thin vector database where you're sort of creating these vectors on the fly and throwing it away, but you're not persisting that, right? It's when you're trying to start persisting it, retrieve it, that's where a lot of other challenges come in. You can avoid all of that by sticking with what we have built over 40 plus years, and you don't need to train new engineers for this. There's no new development for this. It's all a
Absolutely.
shim layer.
Absolutely, yeah. I mean, that was a great insight, right? So, like, at end of the day, what you need is like the same features of databases, right? So, like
Yeah.
consistency, asset compliance, right?
Yeah.
And then for a new age world, the ability to
Yeah.
scale, give the
Yeah.
performance in terms of sub milliseconds, and so on,
Yeah.
right? That's
Yeah.
what you need out of data infrastructure. So, you don't want
Yeah.
it to be rigid, otherwise, it becomes dark data. And at the
Yeah.
same time, you want all these guarantees to make sure that your application is flawless, right? So, that's
Exactly.
what is required. So,
Yeah.
this
Yeah.
is great. Thanks, Vikram, for these insights. This was very helpful.
Sure.
And
Mm.
next episodes, guys, we have
Mm.
a beautiful demo of building a GenAI powered application again based on SQL agents talking to Cockroach DB. That should give an insight of how to build stuff. So, thank you, Vikram, for your presence, and it was really enlightening. And thanks again. See you.
Thanks, Paresh. Thanks a ton for having me.